Welcome to the pre-calculus notes for right triangle trigonometry for chapter 4.3. Go ahead and write your name and what period you're in your notes. Okay, and the first thing you want to do is copy down the right triangle definitions. So we're going to have sine is going to be the opposite over the hypotenuse. The cosecant is going to be the inverse of that. So you're just going to flip that over to the hypotenuse over the opposite. Cosine is adjacent over hypotenuse, so the secant is hypotenuse over adjacent. Tangent is opposite over adjacent, so the cotangent is going to be the adjacent over the opposite. Okay, so these are all written in the angle theta, so that's this one right here, and you've got this little person over here. So from this angle, the opposite is straight across, the adjacent is next to it, and the hypotenuse is always opposite that right angle. Okay? So for our first example, we're going to find the exact values of the 6 trigonometric functions of theta. So here's the angle theta, and we have two sides labeled. We have this side over here, which is 5, this side over here, which is 13. So the first thing we need to do is find the value of this adjacent side. So since it's a right triangle, we can use the Pythagorean Theorem. We know that the hypotenuse is 13, so we're going to say 13 squared is equal to the two legs squared added together. So one of them is 5 and the other one is x. So 5 squared is 15, 13 squared is 169. Subtract the 25 from 169, which gets you 144. And then you're going to take the square root of both sides, which gets you the 12. So this side right here is 12. So the first thing we want to do is find the sine. Sine is opposite over hypotenuse. So from angle theta, the opposite is 5, and the hypotenuse is 13. So you're just going to write the ratio 5 over 13. Remember that the cosecant is the inverse, so just flip that fraction to 13 over 5. The next ratio we want to find is the cosine. Cosine is adjacent over hypotenuse, so here's the angle theta. The adjacent is 12, the hypotenuse is 13, so you write the ratio 12 over 13. For the secant, you flip it and give the inverse here. Okay? Tangent is opposite over adjacent, so from angle theta, we have the opposite, which is 5, the adjacent, which is 12. The cotangent is the reciprocal here. Okay? All right. For the next example, we want to find the values of x and y. So we have our angle here that they gave us, 15 degrees. That's the one we want to work from. And so we're going to first figure out side x. Well, we know the 14, and we want to find x. So 14 is obviously opposite. And the x is adjacent. So of the 3 trig functions, which one uses opposite and adjacent? That would be the tangent. So we're going to say tangent of 15 degrees is equal to the opposite, which is 14, over the adjacent, which is x. We're going to then use the, make this into a proportion and do the cross product. So if we put over 1 here, 1 times 14 is 14, and then x times the tangent of 15. And to get x by itself, we're going to divide by the tangent of 15, and then you're going to plug this into your calculator. When you plug this into your calculator, you want to make sure it's in degree mode. Okay? So if your calculator says anything other than DEG, or sometimes it's just a D, you're going to want to make sure it's in the degree mode. Hit the 14 divided by the tangent of 15, hit the equal sign. You should get 52.2487-ish. Okay? Then to solve for the side y, we're going to look and see which trig function to use there. I mean, technically from here, since now that you know 2 sides, you could use the Pythagorean Theorem, but I'm going to use another trig function. So from here, from angle 15, I know opposite and hypotenuse, which is sine. So we say the sine of 15 is equal to the opposite, which is 14, over the hypotenuse, which is y. And again, make a proportion and do the cross product. So 1 times 14 is 14. Y times the sine of 15. Divide both sides by the sine of 15. Punch it in your calculator. You should get 54.0918. Okay? All right, for the problem on the right, this time it's this angle up here, 41 degrees. And let's solve for x first. So x is the adjacent and 58 is the hypotenuse. So we're going to use the cosine. So cosine of 41 degrees is equal to the adjacent, which is x, over the hypotenuse, which is 58. Make it into a proportion by adding a 1 in the denominator here. 1 times x is x. 58 times the cosine of 41. Punch it in the calculator, hit the equal sign. Okay? Then to solve for y, we're going to look and see this is the opposite and this is the hypotenuse. So we use sine. Sine of 41 is equal to the opposite, which is y, over the hypotenuse, which is 58. Do the cross product again. 1 times y is y, and 58 times the sine of 41. If you punch that in the calculator, make sure it's in degree mode, and you get 38.0514. All right. This time, we want to find the value of theta and the value of phi. These are just both Greek alphabet letters. And so they're just referring to 2 different angles. So we want to find the 2 different angle measures, the theta and the phi. Sometimes you're just going to see them labeled A and B and C, or you're going to see these special Greek letters. Okay, so let's do, looks like phi first. Okay, so this one over here, we know from this angle, we know the 25 and the 65. So 25 is the adjacent and 65 is the hypotenuse. So adjacent and hypotenuse is cosine. So the cosine of that angle, we don't know its measure yet, is the adjacent over the hypotenuse. Now when you're solving for the angle, you actually have to use the inverse. So on most calculators, it's a shift button or a second button, and it's usually a different color. So on my calculator, it's green, but on yours, it could be gray or white or orange or whatever. So you want to hit that shift or the second cosine. Make sure it has the little inverse symbol, which is a little -1 in the air. Type in the ratio, 25 to 65, and you usually have to fill in the parentheses for it, and then hit equals, and make sure you get 67.3801. If you don't get that, your calculator might be a little different. Sometimes different brands, you have to go in a different order. So I'll look at it or help you if you're in class. If you're at home, you can send me an email. Okay? All right. For the other angle measure, we're going to use sine, because from here, it's opposite and hypotenuse. And then you're going to do the same thing. You're going to take the inverse of both sides. Make sure you hit the second or the shift first. Then when you type in the ratio, hit the equal sign. All right. The problem on the right, we're going to do, it looks like phi first. So from here, we've got opposite and adjacent, which is the tangent. And then we're going to do the ratio of the opposite and the adjacent. Make sure you plug in the calculator correctly. Hit the equal sign. And then for the theta, it's for this one, it's going to be opposite and adjacent, which is tangent again. And then punch it in the calculator, hit the equal sign. All right. This last one just asks you to solve the triangle. When you see directions that say solve the triangle, it just means it wants all 3 angle measures and all 3 side measures. Now, these triangles are all right, so you already know at least one of the angles is 90 degrees, and then they have to give you 2 other pieces of information, either 2 sides or an angle and a side. Okay? So you really have 3 pieces of information already. You just need to get 3 more to get all 6 pieces. Okay? So for this one on the left, we're going to get the 2 angle, we want the other 2 angle measures and 1 of the sides. Notice that they gave us 2 of the sides. So one way, or to get the third side, we can use the Pythagorean Theorem, right? Because we know these 2 legs, so 6 squared and 10 squared. That's 36 and 100. So 136, take the square root, and you'll get roughly 11.66. So now we know all 3 sides, 6, 10, and 11.6. Now we just need all 3 angles. One of them we know is already 90, so we just need the other 2. All right, so let's do this one first. All right. So I'm going to use the 2 given measures. Can you use the one that you just figured out? Sure, but it's a decimal. So I'm going to use the 2 that aren't decimals, which are the opposite and the adjacent. So I'm going to use tangent. And because I'm looking for the angle measure, I'm going to do the inverse. So hit the second or the shift for tangent. Do the ratio of 10 over 6. And you get roughly 59.04. All 3 angle measures should add up to 180. You know this one's 90, so that leaves you with 90. So 90 minus the 59.04, that means the other angle measure is 30.96, if you're rounding. Okay, and then the last problem, this time they're giving us an angle measure and 1 of the sides. So to get the third angle measure, we know this one's 90. That means these 2 are left for a combination of 90. So 90 minus 18 is 72. Now we have all 3 angle measures, and we just need the 2 other sides. So let's solve for x first. So from the 18, 35 is the opposite, and x is the adjacent. So we're going to use the tangent. So the tangent of the angle measure 18 is going to be the opposite, which is 35, over the adjacent, which is x. So go ahead and make it into a proportion and do the cross product. So 1 times 35 is 5. X times the tangent of 18 is x times the tangent of 18. So we're going to divide both sides by the tangent of 18. You plug that into the calculator. And 35 divided by the tangent of 18 is approximately 107.72. Now from here you could do the Pythagorean Theorem, but I'm going to use another trig function. So the other trig function to get the y. So opposite is 35, hypotenuse is y, so I'm going to use the sine. So sine of 18 is the opposite, which is 35, over the hypotenuse, which is y. Again, do the cross product, and then divide by the sine of 18. So 35 divided by the sine of 18 is roughly, or approximately, 113.26. Now we have all 3 angle measures and all 3 sides. So if it says solve the triangle, that just means it wants all 3 angles, all 3 sides. It has to give you at least 3 pieces of information. So you're really solving for 3 pieces of information.